Morning, everyone. Thanks for joining. I'm going to be taking you through the Charmed Operator Development Workshop this morning, this afternoon, this evening, wherever it is that you've come from. We've also got Tom in the chat, Tom Haddon, who you should see in a moment. Tom will be there to try and do any basic troubleshooting as you go. You can drop questions in the chat and he can answer them there and then he might take some of them to me as we hit the various section breaks. So this session will last about 2 hours. We'll begin with some kind of concepts around Juju, dive into a bit more detail about some of the things you've already seen. And then we'll actually get straight into live coding an operator to deploy a small landing page so you can get a feel for what it's like to work with Juju. I'm going to use a couple of different views throughout. So if you make your browser window a little bit bigger, you should now be able to see the slides, and I'll kind of get shrunk up into the top right there. What I'm going to do now is just put up some instructions about how to get set up for your development environment. So we're not going to be hitting this probably for about another 10 minutes or so. So it should give you enough time to get set up with a micro-K8s cluster, get Charmcraft installed, and get Juju installed. You'll note that the slides for this presentation are available at jnsgr.uk/demo slides. And there's also a gist set up, the link for which is on screen. And that has a single file per slide, per numbered slide. So any commands that you want to copy and paste, any pieces of code that you want to copy and paste, you should be able to do that in a relatively easy format. I'd like to also just mention our charming community. So firstly, charmhub.io is where you can find the open operator collection. So all of the current operators that we host that people have built. So people in Canonical have built, various members of the community have built. So that's definitely a place to go and check it out. You'll also spot the Hello KubeCon charm featured front and center, which is the charm that we're going to be building today. Also worth checking out our discourse, which is our community forums, relatively active, and there are folks all around the community from inside Canonical and out who hang around in there and are willing to answer any questions. And it's also where all of our documentation is hosted. So if you spot anything in our documentation, you want to add something, or you find a mistake, or perhaps you just want to write some documentation about something, that's something that you can do. And finally, we host a Mattermost instance for the community at chat.charmhub.io. Mattermost is a multi-channel instant messaging application similar to Slack and others. And again, there's plenty of people from inside and out of Canonical who hang around there to talk about Juju, talk about how to build charms, etc. So a good place to go and get help. We're going to go a little bit deeper into some of the concepts that Rui's already covered and that Mark and David spoke about in that first session, just so that we've got the best understanding possible before we start actually writing our own operator. So firstly, let's dig into a little bit more about what the controller is in Juju. So the Juju controller is essentially the management node of any deployed Juju cloud environment. The controller is just like any other machine created by Juju. So in the case of Kubernetes, it's just deployed as a container, but it might also be deployed as a Lexi container or a virtual machine, depending on your cloud environment. The controller is essentially what connects the Juju CLI, and therefore you as an application administrator with the underlying cloud API, be that underlying API AWS or Azure or Google Cloud. It can also talk to VMware, a bare metal stack using MAS or Kubernetes in this case. The controller really runs an API server and has access to an underlying database whose overall purpose is to keep the state or keep track of the state of all of the deployed models, applications, and machines in that environment. While all of the controllers are essentially the same, there are three kind of common configurations you might come across. And the first is a cloud-specific controller, which we'll be using today. So a cloud-specific controller is just a controller that only has models from one kind of substrate. So in this case, if you follow the development setup guide, you'll have a controller that's set up just to talk to Kubernetes models. However, you can actually add models from different substrates to any controller. So that same controller that you've just provisioned onto your micro-K8s installation, you can also add models for VMware, for AWS, for Azure, for Google Cloud, for all of the supported substrates that Juju can talk to. And finally, there is a hosted Juju controller called Jazz, or Juju as a service. You can check that out at jazz.ai, and that's essentially a free-to-use hosted Juju controller provided by Canonical. So if we take a look at what models and applications really mean for Juju, each controller manages a number of models. And models are really just a workspace for a group of deployed applications. So each one of the blobs you see on that diagram there is a charmed operator, also basically an application, right? So it could be PostgreSQL, it could be Mattermost, it could be WordPress, it could be some element of Kubeflow. And each one of those operators, the idea is concentrated on delivering the best version of that application, right? Doing all of the things you need to do to operate that application throughout its life cycle. So what's actually inside an application that's deployed with Juju then? So you've got the Juju CLI, which is the bit that you are kind of interacting with, talking to the Juju controller using the API on the controller. That controller emits events to a Juju agent inside your application. So that agent always runs. It's the first thing that runs in your Charm container. It also runs in various Lexi containers and virtual machine deployments if that's the method that you choose to use Juju. And the agent essentially intercepts those events from the controller and then decides which bit of your charmed operator code to invoke. So you as the Charm developer are essentially writing callbacks for the various lifecycle events emitted by that controller. The controller would, for example, emit an event when it installs the charm. The agent will get the install event and it'll invoke the install event handler in your charmed operator, which will then do whatever it needs to do to bootstrap the application. And likewise for configuration changing events, for relation events, for upgrade events. So essentially the agent is always the thing that gets those events from the controller, invokes the right piece of your charmed operator code, which ultimately drives your application. The kind of dotted replicas you see behind that application on screen there illustrate different units of an application. So when you scale applications in Kubernetes, you get more units of that application. The default deployment of most applications is just one unit. And as you scale it out, you get more and more units. One thing to note about this particular approach is that because the Juju agent and the charmed operator and the application are kind of all packaged up in each unit, it means that the operator actually scales with the application in this model. So kind of differently to how some of the other Kubernetes operators work, the operator is always right next to the workload running on the compute platform, best place to kind of operate it irrespective of kind of connectivity, network latency, etc. So if we look a little bit deeper into charmed operators then and what they really are, a charmed operator is really just all of the domain knowledge and expertise that's required to effectively operate software distilled into nice, clean, maintainable Python code. Application code for many applications that are used in enterprise these days is open source, and many enterprises are using these applications to solve the same kind of problem. So why not share the operations code as well? The charmed operator framework and therefore charmed operators when they are packaged essentially mean that you can package up your ops code and distribute that under any license you like and get as many people to benefit from it as possible. And hopefully you can also benefit from the development of other charm authors with various integrations that they can provide. And we also provide developer tooling here to kind of aid that code sharing process. So as I mentioned, charms are just ops code packaged, and you'll have likely used other tools that allow you already to carry out those normal lifecycle events, right? So your standard install, configure, update, remove, scale application type events. But where our operators really start to come into their own is in our ability to specify day two actions for your operators, right? So you might define an action as a charm author that allows you to do some specific backup for your application, maybe a snapshot, perhaps a replication. Maybe you're going to change a user's role in a database. And really the idea behind actions is to encapsulate all those things that a normal human administrator might need to do sort of beyond day one, right? Beyond the deploy. And finally, we have the ability to define integrations between charmed operators. So in Juju land, those integrations are known as relations. And you can see there's a few: relate MySQL, relate LDAP, relate proxy. And we'll go on to define a relation later on in our demo charm and show you exactly how you might do that. But really the idea is that charm developers should be the experts in those applications and therefore do the heavy lifting to understand how best to integrate that application with other things. So what actually happens then when you're deploying a charmed operator on Kubernetes? It's slightly different to how it works on bare metal or on a VM, but kind of follows the same model. So when you add a Juju model to your Kubernetes cluster, you're essentially creating a Kubernetes namespace. When you deploy an application, you're creating a stateful set with a single replica by default. And when you scale the application, you're essentially just altering the number of replicas for that stateful set. You'll notice that here you always use the Juju CLI for this, right? So it's Juju add model, Juju deploy, Juju scale application. And that's similar, that's one of the kind of selling points for the charmed operator framework is all of your operators will have a nice consistent UI because they're all going to kind of be interacted with through the Juju CLI. So if we take a little bit of a look into what's in each of those pods as part of that stateful set, inside the pod, you get 2 containers, assuming you specify just one workload container, right? So you always get a charm container in the pod, that's the sidecar, and then you also get the application container, which is the workload that you're trying to drive. The charm container is what houses the Juju agent and therefore invokes your charmed operator code. And the application container can just be any upstream OCI image. So you could take the upstream container for MySQL, the upstream container for Mattermost, whatever it is. And we do some work under the hood to make sure that you can start that and manipulate it with your charmed operator, which I'll cover in just a second. Note that because your charmed operator and your application are in the same pod, they'll always scale kind of with each other, and you'll always end up with the operator scheduled on the same node as the application. So they'll never end up kind of across some kind of network boundary or suffering some of the challenges that you see with distributed computing. So the way we enable kind of more fine-grained control over these applications is with a little kind of clean, opinionated, and very container-centric init system that we've developed called Pebble. So Pebble is lightweight, it's API-driven, it kind of behaves similarly to something like S6 or Supervisor D or Runit. And it's embedded automatically into the pods by Juju when it deploys the application. So we use an init container to go and fetch the latest version of Pebble, and then we create a volume mount inside your workload container, which automatically injects the Pebble binary into the container, overrides the entry of the container, and then you instruct Pebble how to start that workload within that container. And the reason we do this is because it means you don't have to custom build images to use Pebble. It's just available in the container when you need it. All the communication between the Juju agent and between the application is through a shared socket that Pebble creates when it starts up. So it creates the socket and drops it in a shared volume that both the workload container and the charm container have access to. And what Pebble fundamentally allows you to do is start and stop services with a set of environment variables, push and pull files in and out of your workload container, and a few other things that allow you to kind of manipulate processes running at the same time. So I've just seen a couple of questions come in there. So Pat's asked if we can specify resource constraints on that sidecar. You can specify resource constraints on the operator itself. So later on, we'll cover the metadata.yaml file. And in the metadata.yaml file, you can specify resource constraints fairly similarly to how they work in Kubernetes anyway, right? So you can specify how much CPU and memory you want your application to use. So if we look at how Pebble is configured, I just want to make sure we kind of disambiguate the term layer. So Pebble has been designed specifically for use with containers, and its configuration is handled in layers, which are sort of analogous to how the layers work in an OCI image, but they are distinct. So if you hear me talking about Pebble layers and pushing and pulling layers in and out of containers, what I'm actually talking about is the Pebble configuration. And the reason we do this is because you could theoretically bury your Pebble layer configuration in an OCI image. So you could custom build an OCI image with a bunch of Pebble layers in it. And if you're using sort of multi-stage builds to build up containers from a set of known base images, you can kind of manipulate those layers at each layer and kind of gradually specialize them to get the running configuration you want. We anticipate that most people probably won't do this. What they'll probably do is use an upstream container image and populate Pebble with its configuration at runtime using the API. And that's what we're going to do today a little bit later on in the demonstration. The layering system just gives a really nice kind of level of flexibility, both for image builders who want to integrate them into their images, but also for administrators who want to kind of get precisely what they want at runtime. And you can see the example on screen there. At day one, you might deploy an application, tell it to run a simple command, and that you want that command to run automatically when Pebble starts, which is what's indicated by the startup field. But then at day end, perhaps you want to manipulate some environment variables, so you just specify a lightweight layer with just the config you want, specify override merge and throw that at the Pebble API, and Pebble will kind of combine any existing configuration layers it's got with what you've just given it and come up with a new kind of running configuration. So why would you use the charmed operator framework? I've already seen some questions in here about, are there any plans for other operator frameworks to kind of be supported? Do we just support Python, etc.? So the reality is that you can actually write charms in any language you like. You can write them in Go, you can build one with just Bash, but really we recommend that you use the charmed operator framework, and all of our tooling is kind of built on that assumption. And really that's because it allows you to keep your ops code nice and simple. So we've got a nice number of kind of abstractions in the framework that help you kind of ignore some of, or kind of abstract away from some of the details and just focus on doing, what your operator needs to do for your specific application. It also means that you'll get a really consistent kind of UI for all your operators. So we think that one of our kind of core benefits over existing Kubernetes operators is no matter what the application, your operator will present itself to administrators in terms of its UI very similarly. You'll always use Juju relate, Juju config, Juju deploy, Juju scale, rather than kind of a whole bunch of bespoke CLI tools, some of which are integrated into kubectl, some are not. We also provide a comprehensive unit testing harness, which is also fairly unique in this space. So the unit testing harness allows you to kind of fully initialize a charm and simulate its life cycle and provide some guarantee that it's going to behave how you'd like it to behave in production. And there's also some good precedent for doing end-to-end testing and functional testing with a framework called Zaza. And also with our developer tooling and kind of our facility for charm libraries, which we'll unpack a bit later on, makes for much simplified code sharing and much easier integration between applications. So what are we going to do in the workshop today? So we are going to initialize a brand new charm using Charmcraft. We'll then modify the template that spits out in order to start a workload that we would like to use. We'll handle some specific configuration. We'll define a day to action. And then we'll use a charm library to integrate integrate with another application by using the kind of definition of that relation that's specified in the library. That will all become a bit clearer later on. And then finally, we'll do a quick overview of how you might unit test the operator. You'll shortly have a landing page similar to the one on screen now deployed. And that landing page will kind of point you to all the various places you can interact with our community. So to the discourse, you'll find us on GitHub. It'll show you where the Mattermost is. And it'll also link you to all of the various bits of documentation for Juju and the Charmed Operator framework. There are two key repositories that we're going to use today. The main one that you probably want to check out for the remainder of this demo is jnsgr.uk/hello kubecon. And that's the source code for the operator that we're going to write. And if you look at the different branches that are available on that repository, you will see a different branch per stage of the demo. The way that I recommend you follow through this, because it is quite a lot of typing if you're going to kind of follow through, is to, at the start of each stage, kind of check out the branch for that stage, follow through the code as I'm explaining it, and then deploy it at the end of the stage. And that way you'll be able to kind of keep up with the discussion, fire any questions at us in the chat, that sort of thing. What our application is actually, what our operator is going to do is it's going to deploy a copy of a little custom web server that I wrote really to scratch a personal itch some time ago. So all it is a simple web server written in Go that will serve a static web page if you give it a web root environment variable. But otherwise, it serves up a list of kind of short URL redirects based on a kind of plain text map, which you can host at a URL. So the links you see at the bottom of the slide, for example, jnsgr.uk/demo gist and the demo slides are short URLs that are created by an instance of this application that I host myself. And what will happen here is we'll use the upstream container image for GoServe, which is just a completely blank scratch-built container image with a statically linked binary in it. And we'll use the sidecar part of the operator to fire up before we launch GoServe, go and fetch a landing page and drop it into a shared storage volume, configure the environment variable so it knows where to find its redirect, and then start the application. And like I said, we'll also handle configuration and implement some day two actions or a day two action. Finally, we'll also show you how to integrate this charm with another charm and show an integration with a Kubernetes ingress controller using that mechanism. A reminder that this is the development setup that you'll need to carry on with the rest of this demo. You can kind of get a good idea as to whether this has worked by once you're at the command line and you've run those steps, you should be able to run Juju status and see that you're in the development model, but the model is empty at the moment. If it looks like that, then you're good to go. If it doesn't, then feel free to fire questions at Tom in the chat and he will do his best to help you out. I'll just take a pause for 30 seconds or so to have a quick scroll through the chat and see if I can answer any questions and then we'll get started. How are we doing? Yes, so Dominic, that's an interesting question. This would be a good way to create generic autopilot operators. Yes, indeed. So that's really the goal here, is that we can provide a comprehensive enough framework with enough of those kind of critical lifecycle events defined that the operators can essentially drive themselves, right? That's exactly the goal. Cool. I think that's pretty much it for now. So we'll get started. Oh, hang on, one last one. Are there some plans to make this framework bigger than Canonical alone, bitware regards to single-vendor solutions? Yes and no. So in a sense, it's already bigger than Canonical alone, right? It's an open source project. We're very much open to contributions to it. You know, you're more than welcome to fire pull requests against that framework. And we're not really interested in tying people to Canonical as such. At the moment, the only framework that can kind of deploy these operators is Juju. So I suppose in that sense, there's a bit of lock-in. But again, Juju is an open source project that's been around for 10 years or so now. And really our goal is to support as many of those substrates that people need as possible, right? So while you would be choosing to use Juju and the Charmed Operator Framework, which are broadly canonical technologies, you are free to use them with bare metal deployments. You're free to use them on AWS and Azure and Google and VMware, OpenStack, Kubernetes, right? So we're trying to support as much as possible. And we really do encourage people to contribute to both the framework and to Juju itself where possible. So let's get started then with the demo. So if you've cloned the repository, the Hello KubeCon repository, if you were to check out the one specify workload branch now, you'll get all of the code to kind of get you through to the end of this section so you can follow through as we go. So what we're going to do first is just create a new charm. So we're going to create a new directory and run charmcraft init in that directory. And then I'll walk through the different files that are created by that template, just so we understand the kind of anatomy of the charm. There's more detail on that at the docs link at the bottom of the page. So that's been very recently updated, and it will show you a little bit more of an in-depth description of what those files do if you need to refer back to it later. So if I were to just create myself a new directory, jump in there, and then I will just run charmcraft init. Okay. If I just drag the sidebar out there for a second, we'll have a quick walk through what we've got there. So right at the bottom of the list, we've got run tests, which is just a simple bash script that we'll use later on, which will run some unit tests and some code linting for us. You've got two requirements files. The sort of plain requirements.txt is a standard Python requirements.txt, and those are all of the requirements that your charm will require at runtime. In this case, we've just specified the operator framework at this point. There's also requirements dev, which is all the things that you might specify for a development environment. So in this case, coverage and Flake 8, but you might include things in here like black or tox or various other dependencies like that. README file is fairly self-explanatory. And then the metadata file is the first kind of really charm-specific file that we'll look at, right? So there are kind of two types of information in the metadata file. You've got the kind of purely informational stuff, so the name and description and summary of the charm. And then you've got some more information about the container, in this case, just the containers that are going to get deployed by the charm. And then a set of resources, which in this case is a container image or a reference to a container image, so that when Juju deploys, your application sees that it needs to deploy some containers, it knows which OCI images to deploy. We're going to use this file fairly extensively throughout, so we'll get a bit more detail as we go through. There's a license file, which is pre-populated with the Apache 2 license. You're obviously welcome to license your charms however you like, but we do recommend the Apache license. And there's a little bit more information about why that's the case in the Charm Hub manifesto. The config.yaml file is where you specify any configuration options for your charm. So we'll come back to that a little bit later on. And likewise for the actions.yaml file, which will specify kind of the different day to, onward actions that you might want to create. Juju ignore behaves a little bit like a git ignore file. When you build your charm into a .charm file, when you package your charm up, this is just used to make sure you exclude various files from the working directory, so they're not all included in the charm. We've then got a tests folder, which we'll come back to a bit later on, and we'll just take a look at the kind of main source code for the charm. So the entry point for this charm is at src source/charm.py, which is marked as executable on the file system, and always specifies a shebang at the top of the file, so so that when the charm code is invoked at runtime, the machine knows which interpreter to use. In this case, Python 3. We'll have a quick scroll through this then to kind of get a feel for what we're looking at here. So firstly, you'll notice we're defining a class which inherits from charm base. So when you're writing charms using the charmed operator framework, they all need to inherit from charm base. And charm base essentially just means that the class is nicely set up with the various primitives like self.framework that allow you to listen into those events that are going to be emitted by the controller. And we'll also give you access to the underlying Juju model, which we'll look at in a bit more detail later on. You'll also see this stored state being initialized in the class. So every time the controller emits an event to the agent, your charm code is invoked, which essentially means a new instantiation of this class is made. So it's difficult to persist data across invocations of this charm without some notion of a persistent data store. And that's exactly what this is. This stored state kind kind of abstraction here allows you to persist data into the controller database that you can kind of rely upon in between invocations. And you can see here in the init method of the template, we're setting some defaults in that. And there's a bit more information on this again if you go to juju.is/docs/SDK and look under the framework constructs section. There's a bit more information about stored state. We're not going to use it too much today. And then you'll notice that these self.framework.observe lines, right? So here we are observing in like specific events. So these are all events that would get emitted from the controller. And then we're assigning a callback to those events, which are then handled as private methods on the class throughout the source file. Finally, we've got this kind of entry point down the bottom here, which is just used kind of by the agent at runtime to make sure that the right bits of your code get invoked when the agent is responding to events. One thing we'll also do before we carry on is just double check that we've got a virtual environment set up and we've got all of those dependencies installed. If you're on Ubuntu, you can first install the virtual env package with an apt install Python 3 virtual env, and then we'll just create a virtual environment, source it into our environment, and then install the requirements from the dev.txt. So I'll just do that now. So I've already got the virtual environment tools installed. So I'm just going to run virtual env venv, source that environment, and then install the dev requirements. Okay, I'll just take a quick pause and have a look through the questions. So Pat, looks like I have to restart my terminal to pick up the new group post snap install. Yeah, so one way is you can log in and log out, and that will get you straight into the microcates group, but is a little bit kind of perhaps a little bit brutal. You can also run new group, as in new GRP microcates, and that will work for that session only. So if you close the terminal, open another one, you'll have to run new group again. So carrying on then, we're now going to get into starting our workload. So we're going to do that initially by just updating the metadata.yaml file. So we'll fill out some of that metadata with a description and a name for the charm. And then we'll start adjusting the containers and the resources map. So the containers map is where you specify all the containers that your operator will run. Note that for each container that you specify in this map, each of those containers will exist in every pod. So by default here, we've obviously specified one container, which means each pod will have the charm container and a container named GoSherv. If we were to add another container to this map, then each pod would have 3 containers, and on and on and on. And this can be used for where you've got dependencies on other applications that kind of don't need to be accessed by multiple units, for example. So you might just choose to run a couple of containers in a single pod and use the operator to drive both of those in that same pod for easier scaling. But it may also be sensible to rely on a separate operator for those dependencies and use relations. It sort of depends on the complexity of the application and the environment you're deploying to. You'll also see the resources map there. So for every container that you specify in the containers map, you then need to specify an OCI image resource to tell Juju where to go and find the OCI image to deploy for each of those containers. So if I just drop back into VS Code then and open up the metadata file, we'll just make those adjustments now. I'm going to grab some of the longer bits of text and copy and paste them in so you don't just have to sit and watch me type. And then we'll do a few changes by hand. So I'll just get rid of these template items. And then we'll just do a quick find and replace essentially on these HTTP bin. And that should pretty much be it for now. The next thing we're going to do is we're going to adjust some of the charm code to start implementing our first event handler. So you'll remember that in the code we had that HTTP bin Pebble ready handler. So there's for each container that you define, you'll remember that Pebble is loaded automatically into that container and Pebble becomes the entry point. So by default, when your containers start in the context of a charmed operator, they'll start Pebble first, and Pebble will then essentially report to Juju that the API is ready and it's good to go. As soon as that has happened for each container, you'll get an on container name Pebble ready event emitted, right? So in this case, it would be the GoSherv Pebble ready event. If we had a container called Redis, you'd get the Redis Pebble ready event emitted once the Pebble API was up and running in the Redis container. If we just do a quick walk through the code we see on screen then, the Pebble ready events all carry an event parameter, which in turn carry a workload parameter, which refers to the individual container that the event is about. So essentially, we can pick up a reference to the container from this event because this event is only specific to one container. We then define an initial Pebble configuration in the form of a layer. You can see there we give it some metadata, a summary and a description, and then we specify a map of services, in this case, just the one service called GoSherv. So similarly to how you can have multiple containers in the pod, you can also specify multiple services in your Pebble layer, and you can also define a service ordering as well. So you might define 3 or 4 different services here and say, this one needs to start before that one, and they both need to start after this first one, etc. Finally, once we've defined the layer, we'll add it. So container.addLayer is essentially hitting the Pebble API to add that layer to, and we specify combine equals true, which essentially says if there happens to be a layer already running in this Pebble instance named GoServe, then override it or do whatever is specified in that layer. And then finally, container.autostart will start any of the services that were specified in the layer with the startup enabled flag. And then we set an active status on the operator, and I'll show you exactly what that kind of means and where that shows up in a little while once we deploy the charm. So if we just go through and make those changes now, we'll open up the charm code. I'm just going to do a little bit of cleaning up because there are some things here that we're not going to use. So I'm going to drop the stored state stuff. We're not going to use that for this demo. I'm also going to get rid of all of these other event handlers because we'll come back and implement those in a more specific way shortly. So let's just get rid of that. And then we just need to do a bit of cleaning up here to make this a bit easier to read. And I'm going to do a bit of a find replace on HTTP bin and make sure that we're starting GoServe and not HTTP bin, which is what the template does. So the command for GoServe is actually just, I mentioned there was just a single binary in this container at the root of the file system. So it's just /GoServe. And we're also going to change the environment config slightly as well. So I'd just like to talk a little bit about this redirect map. You'll remember that I said that this was going to essentially serve up a bunch of redirects. So if we grab that URL and just browse to it, let me just find the browser window. There we go. You'll see that that is essentially just the raw part of a GitHub gist that says Juju and a URL, ops and a URL, Pebble and a URL. So that means that once your service is up and running, if you were to hit the kind of IP address of the pod and go to /docs, it will redirect you to that URL there. If you go to /ops, it will redirect you to that URL there. And the nice thing about this is it's a GitHub gist, so you can just browse to that gist at any time and edit it and kind of add short routes that you might want to share if you've got a nice short domain like the one I've been using. I'll just get rid of that browser again. So I think we're all in good shape for the code now. We've got our Pebble layer. We've added it into the Pebble API. We've added it, into Pebble using the API. And then we're saying also start, which essentially means that it will start the GoServe command with that environment variable. And then we'll set an active status. There are 4 different types of statuses by default. So there's active status, which means everything is good. You can actually, in any status, specify a message here, which is deployed in the Juju status output. The guidance generally is that you don't set a message when the charm is just kind of happy and doesn't need anything and it's doing what you would expect it to do. There is also maintenance status, which you might do when there is some long-running application going in kind of machine charms or non-Kubernetes charms. This was traditionally used when you were installing packages, writing config files, reloading services, etc. But broadly, you should expect from a maintenance status that the charm knows what it's doing and should be expected to get itself back to active status without any further intervention. There's also a blocked status, which essentially means I need a human. So somewhere in your charm, if you were to set, rather than active status here, if we were to set blocked status, that would show up in the Juju status output, and that would essentially be the charm saying, help me, I need, config setting, or I need a relation defining, or there's been some kind of error that I can't recover from. We're just going to set active status in this case. So now we're actually going to build our charm and deploy it. So we'll run charmcraft pack, which is going to create us our hello kubecon.charm file. A .charm file is actually just a zip archive. So for the curious amongst you, you can just unpack that with your favorite archive manager and have a look inside it. You'll find your charm code and essentially a pre-populated virtual environment with all of the Python dependencies that your charm needs at runtime. Once we've packed it, we'll then deploy that charm. And because we're deploying locally and we're not relying upon the charm hub to tell us which image to use because this charm hasn't yet been published, we'll specify the OCI image we want to use manually with the -- resource flag. And then we'll watch the output of Juju status and watch that charm deploying and verify that we can curl the pod IP and that our redirects are working. So I'll just do that now. I'll also show you kind of how I like to deploy charms and kind of how I set my terminal out. So I like to have the Juju debug log running all the time, which kind of shows the output from the logs in real time of the Juju controller and the model. I also run the watch command you see on screen, and I actually have that alias to JSW in my terminal just so I can get to it really quickly. And that's essentially just a live output of the Juju status. If I jump into the right directory, I'll just make sure I'm in the virtual environment. We should now be able to run charmcraft pack. And you'll note that we've now got a hello kubecon file, which is a .charm file, which, as I mentioned, is just a zip file. We can run juju deploy / that's not it. There we go. So we're going to deploy that file we just created, and we're going to specify a resource of jnsgr uk/go share, which is a Docker image that I published, or sorry, an OCI image I published at Docker Hub last week. So you should see a bunch of output up in your debug log, and you'll also see the Juju status sort of spring into life as it starts to deploy containers and create the various Kubernetes stateful sets, initialize those first pods, etc. I'll just take a quick look at the chat. Can we define roles for service accounts in metadata.yaml? Yes, indeed. So Tom said there, every single one of your kind of charm containers will have a service account assigned to it. And by default, that has some fairly limited permissions kind of over the model that it's deployed in. You can elevate those permissions to the same permissions that Juju has over the cluster by essentially, now we've run that, well, we've got that application running, we could run Juju trust hello kubecon. And that would essentially elevate the service account that's associated with our charm so that it had kind of cluster-wide permissions. You could then, for example, use the Kubernetes Python bindings and poke about at the Kubernetes API and do whatever you wanted. Hopefully that answers the question. So does the SDK allow for creating Kubernetes resources? So that's exactly it, right? So you would use the Kubernetes Python binding either to apply an existing YAML manifest, which you maybe would template out using something like Ginger, or you could just make individual API calls to say, you know, create this Kubernetes job, create this custom resource definition, etc. It's worth noting that there may well be some kind of stronger abstractions around this stuff coming in the future. This is a kind of first iteration of this sidecar pattern at the moment. So you kind of have to do a little bit yourself with the Kubernetes API. The nice thing about using the Kubernetes API, rather than just firing big, long blobs of YAML at it, is that you can kind of unit test each one of those calls and make sure that you're doing the right thing, right? And you can handle kind of failures very granularly. So not a bad approach. There is an example of that, which you can post a bit later on, deploying the Kubernetes dashboard, which sets up a bunch of custom service accounts and those sorts of things. If we go back to our deployment then, you can see that we've now essentially got into active idle status. So where we set active status in our charm, that's essentially what we've seen there, right? So there's no message off to the right-hand side here, which the charm is just saying, I'm happy, I'm good to go. You'll note that the IP address here is actually the IP of the pod that's been deployed. Microcates actually allows you to get directly to the pod IPs without any messing around. So we should now just be able to curl that on port 8080. And if we go to /ops, we should see we get a redirect to the GitHub page for the operator framework, and likewise for Pebble and for Juju and those various other things that we put into that redirect file. It's also worth noting that if you're not seeing quite as much output as I was seeing in my debug log, you might not just have set the model config. So you can set the log levels for the kind of controller for the model, your individual application. So that line at the top of the slide there will set essentially a warning level for the controller, but your deployed application, your unit will be set to debug level. So when you run logger.debug in Python, you'll be able to see that output. We can also have a bit of a poke about with kubectl now and just do a bit of exploring what's actually happened during the space of that deployment. So if I just switch back to the terminal, try and find something a little bit more clear. If I were to run kubectl tackend development get pods, you'll see that we've got 2 pods deployed. So the first is the model operator, and this was created automatically when you ran Juju add model development, right? So when you run Juju add model, it deploys the model operator into a new Kubernetes namespace, which is named after the model. And that model operator is essentially an admissions webhook, and it sits there to make sure that any of the pods that go into that namespace are correctly annotated so that Juju can manage them. And we'll see an example of that in a moment. You'll also see the hello kubecon pod, and as you'd expect, there are 2 containers running in there, one for the workload and one for the charm. So we'll just take a little bit more of a look at that. So development scribe pod hello kubecon. 0. Okay, so you'll see here then a bunch of kind of additional annotations, including the UID of the controller, the version of Juju that's managed that deployment, the model ID, and the name of the unit. So units are kind of annotated as application name / an ID. We've got one unit deployed, the 0 index, so this unit is hello kubecon 0. You can see that it's controlled by a stateful set named after the application itself, and that we had an init container, and that's what fired up and essentially made sure that Pebble was available and the charm code was available in a persistent volume. And subsequently, we then end up with the charm container with your charm code and that service account that we just spoke about already mounted. And then the Go Sherv container, you can see that that's got Pebble bin mounted into it, and it also has had its entry point overridden so that we're running charm bin Pebble, and we've told Pebble to come up in hold mode, which means if it doesn't have any configuration, it just fires up, launches the API server, and waits to be told what to do. I think that's pretty much it for that first section. So we're going to move on to handling configuration next. I'm just going to take a quick glance over to the chat and answer a few more questions, and then we'll get going. But if you want to check out the next branch, that'll get you all the code for the next step. So permissions denied from Charmcraft Pack. I'll let Tom help you troubleshoot that one. That one might be a bit difficult to do like this. Universal charms, essentially. So having charms that will do both machines and Kates. That is definitely an aspiration. So right now, you do have to write them separately because the metadata kind of looks a little bit different. But the aspiration is in the future that you would be able to, say, do Juju deploy Postgres, and the charm would know that it was on Kubernetes and do the right thing for Kubernetes, or it would know that it was targeting a VM and it would do the right thing for a VM. We're not quite there yet, which is why you'll see on Charm Hub, PostgreSQL and PostgreSQL-Kates. And that's kind of the convention that we're recommending to people when they're publishing charms at the moment, is to add a kind of -Kates on the end if that application, could feasibly be run elsewhere. If you're deploying something that's obviously Kubernetes focused, like the Kubernetes dashboard, for example, you can just call that Kubernetes dashboard because it's fairly clear that you'd be running that on Kubernetes. How do you replace a charm to pick up a new version? Good question, Pat. We will cover that in just a moment at the end of this next step. But essentially, you'll run Juju refresh the name of the application and then provide a path to the charm. I will cover that just a little bit. You can also do Juju remove application hello kubecon and then just redeploy it as well if you want to start from scratch. So I think looks like Joe's doing a good job of picking up some of these questions. Thank you, Joe. I didn't know you were joining us this morning. Your Juju refresh there, Pat, the reason you've got that is because you're saying Juju refresh hello kubecon.charm. So I'll type this in the chat, but you want to do something like this: Juju refresh hello kubecon, which is the name of the application, and then --path equals hello kubecon.charm. There we go. Okay, so we will carry on then with configuration. So before we do that, how does one set configuration on a deployed charm? So you would use the Juju CLI, and you would say Juju config, name of the application, and then a kind of set of key value pairs for the configuration. And we encourage charm developers to think very carefully about the configuration they expose to users here. Really, you want to try and embed as many opinions as you can, right? Try and get your charm to run the best version of that application, or kind of the most universal version of that application it can, with having some config already defined. And you want to expose that when you're exposing configuration, you want to really be considering the service that that application provides, rather than exposing 100 really fine-grained controls to the user, right? If you've got a really, really advanced power user, then perhaps they might do something like fork it and make those changes themselves. But if you think about the kind of 90-95% case, you want to deploy your charm with the most sensible defaults that you possibly can. So include some default values, include good documentation about what those configuration options do, and we'll see how to do that shortly. Configuration options are specified in config.yaml, as we mentioned earlier on, and it's got quite a simple schema. So it's mostly just a map called options, where each of the keys of that map is the name of a config item. So reading what we've got on screen there, we have one single configuration item called redirect map. You'll also, you can specify default value, a description, and a type. So the supported types at the moment are just string, Boolean, and integer, and that's it. We've basically covered the entire available schema for config. So you can clearly add multiple configuration options, but the schema itself is relatively simple. So One thing to note is that when you specify your configuration, it's automatically parsed by Charm Hub. So if we take a look at the page for this charm here, you can see this is the charm that we're building now. I've published it to Charm Hub. And if we jump into the configure section, you can see that Charm Hub has parsed that config.yaml file and kind of provides a nice view there. Obviously, this is quite simple, so there's just one item shown. So if we jump back into VS Code and just make those changes now, I'm going to drop this template piece here just to make that file a bit shorter, and we'll just rename that to redirect map. Set this to the root file we used earlier on. Not having a good typing day today. And we'll just say this is a URL pointing to a map of redirects. I really can't type today. And then we'll set the type to string and save that file. Next, we're going to do a minor bit of refactoring. We're going to pull our kind of layer generation, our Pebble layer generation out into its own method. And we're just going to modify that initial layer to include a reference to self.config. So from within your charm, you can refer to any of your config options, kind of like they're a dictionary, through the self.config piece. So self.config redirect map will pull whatever the current value of the redirect map config option is into your code for you. Note that the configuration values are read-only from your charm code. So you can't, for example, do self.config redirect map equals, right? You can only read the config from the model. And that's really so that when application administrators are setting the config using the CLI, they can trust that those config values are going to stay set, right? It's not going to kind of randomly change under their feet because of something a charm developer's done. So if we switch back to the charm code, we're going to grab hold of this here and copy it. And we're just going to define a new method here. Should be good. You'll note that we're preceding this function name with an underscore. So it's private to this class. You shouldn't really ever need to call these methods from outside your class. And if you do need to do that, that's what charm libraries are for. So we generally encourage people to make these private methods. I'll just include a little doc string there, and then we'll just return that dictionary we copied from up the top, and we'll just replace this default value here with self.config redirect map. Okay, so that will allow us to change the kind of URL map that we're using in our charm by using the Juju CLI. The next thing we need to do is implement a config change handler. So it isn't enough to just have the layer method. We need some way of actually invoking that. So this will happen when the Juju controller emits a config changed event to the Juju agent inside the charm container. We need to implement a handler for config change so that we pick up that config change from the model, reapply the kind of layer to Pebble if there's been a change, and then restart the service. The config changed event is quite an interesting event. It gets fired at a number of different points throughout the charm's lifecycle. So it's fired very early on in the charm's lifecycle. So immediately after the install event, you get a config changed event. You also get it every time a Juju config command is run. You might also get it as part of a relation, as part of an upgrade. So the config changed event can end up being quite a kind of pivotal method in your charm. There's a bit more detail about the various events and the different types of the different kind of sequences of events at the docs link at the bottom of that slide. I'm going to grab a copy of this config change handler and chuck it into, copy and paste it into the code, and then we'll walk through it line by line to make sure we know what it's doing. So if I just drop that in the charm code just above that new GoShare layer method we've just created, and let's take a look at what this is doing. So one thing to note is that the event here doesn't carry a reference to a specific container. So you'll remember that up in our GoShare Pebble Ready method, I said that the event you got here was specific to a container, and therefore that event kind of carried some information about a container. Here, the config changed handler is actually just about the charm in general, right? So we don't get the kind of specific container information as part of the event, but we can fetch a container that we want to manipulate from the model. So when we run self.unit.getContainer GoShare, what we're saying is get a reference to the container named GoShare that's currently running. We're then going to create a new config layer. So that will call the method that we just ran and make sure we generate a layer with the right configuration. And it will also get the current plan from the running container. So this will hit the Pebble API inside the container and say, what's your current plan? Like, have you already got a configuration loaded? If so, what is it? We're then going to check whether or not the configuration has changed. So if the one we've just generated is different from the one in the container, we'll do something. If it isn't different, we'll just carry on and set an active status. In the case that they are different, that means that the config change is kind of material enough to warrant us stopping and starting the process. So the first thing we're going to do is add a new layer, add that layer we generated into the Pebble plan using the container.addLayer line. We'll drop something into the log, and then we will grab hold of, we'll just double check whether or not the service is running. So this is saying to Pebble, hey, in your layer configuration, is the service called GoServe running right now? If it is, stop it. And then we'll restart it again to make sure that those changes to the environment are valid. I just want to quickly address a question. Does this restart the pod? It doesn't restart the pod, no. So this is one of the benefits of using this approach is you absolutely can choose to kind of handle config a little bit differently and just allow the Kubernetes scheduler to black the pod and restart it. But in this case, what we're actually doing is leaving the pod where it is, and we're just saying to the init system inside the workload container, hey, there's just like a minor change, just restart the process inside the pod. It's also worth noting a couple of things at this point. So firstly, we're not doing any validation on this at this point, right? So really, if you were going to write a sort of production quality charm, you'd probably want to do some validation. First, that there is a value set for the redirect map URL, but also that what's been provided is a valid URL using some kind of regular expression or perhaps some existing library. You'll also note that really in this case, because this application is so simple, these two handlers are sort of doing the same thing, right? So you've got the HTTP bin Pebble, the GoServe Pebble Ready event handler is creating a Pebble layer that starts GoServe and then calling auto start, which starts the process. And what's interesting here is the config change handler will probably fire before the Pebble Ready handler ever fires because it gets triggered sort of immediately after the install event. So what I'm actually going to do in this case is I'm going to drop the Pebble Ready handler. There are situations where you might want to do some kind of one-time initialization or setup inside your workload container, and thus you'd want to keep this kind of handler around and do something slightly different with it. We're just going to drop it here, and we're going to update this event kind of observe thing up here to say on config changed. So now the only event that we're actually observing, the only event for which we're implementing a callback is the config changed event. Okay, so so Pat, interesting you mentioned that. So sometimes pod restarts cause other issues, specifically in very stateful deployments, right? So I imagine this would be relevant to where you're calling from today or from your current employer. If you've got really big stateful databases, a traditional kind of upgrade of a stateful set using something like Helm could trigger a massive rolling restart of all of your pods. And there are some applications that really don't like that. And really what I would say here is you're absolutely, if you've got an application that is quite stateless and can suffer just kind of a rolling restart at, the drop of a hat, then you can absolutely still do that. But if you do have an application where actually you want to bring something down a bit more gracefully and just restart a service within inside a container, or perhaps when a container comes back, you want to bring it down and run some kind of migration on some config or add a field into a database before you bring it back up. This just gives you a really nice fine-grained way to do that. And you essentially just gives you the option, right? You can absolutely default to how Kubernetes normally does it, or you can use this to kind of handle things a little bit more manually. So if we take a look back at the slides now, we're going to do another test deployment. We'll use that juju refresh command that I just dropped into the chat a moment ago. So first we'll just repack the charm to make sure that the built charm has all of the latest code in it, and then we'll redeploy it. So I'll just switch back to the terminal. And where's that tmux session? Good. So if I just run chunk pack, and then I also run juju refresh, we should see a bunch of activity in the status output and also in the debug log. And when it comes back up, we should essentially just have exactly the same functionality, but we'll just do a quick demo to make sure that our config change handler is doing the right thing. Okay, so we're back into active idle, which means we're good to go. So if I run curl /juju, that's not the right pod IP, excuse me, let me grab that. So /juju, we're good. And if I do /ops, we're good. But if I do /ubuntu, for example, it's not there. But if I change the config now so that we've got a different config map that does include Ubuntu, so you can set that to demo root alt if you're following along, you'll see the config changed handler fire. And then we're back to active idle. You'll notice that a second ago, the IP had changed because the pod did get restarted. So when we ran a Juju refresh, we did actually kind of trigger a rolling refresh there, a rolling restart there, because we're running a full upgrade of the application. But here, because we just run a config change, we essentially just executed the code we just wrote, right? So all we've done is just bounce the process inside the container. And now, because I've got a slightly different redirect map, I can curl /Ubuntu. I'm going to set this back to its initial state, and we'll see we now can't curl Ubuntu again, right? So looks like we're all good. Okay, so that brings us to the end of that stage. We're now going to get on to handling some storage and actually serving up a bit of a website using this little web server. I'll just take a couple of seconds to take any questions. You can get the code for the next stage of the demo using git checkout 3-storage. So I'll just glance over the questions now. Mine's in second order of magnitude to refresh. Is there a setting to speed it up? No, there isn't a setting to speed it up as far as I know. It does sort of depend on what the machine is that you're running it on. Mine's happening quite quickly, but I am running on a 24-core Ryzen box with a lot of RAM, so potentially not a great illustration if you're running in a little VM or something. Doesn't look like there are any other... oh, hang on a minute. Do I understand correctly? The charmed operator is not a case operator in a canonical sense. No, indeed, you're absolutely right. So these operators are not like the other Kubernetes operators that you've seen, where essentially you would create some kind of custom resource definition and you'd have a pod running all the time that would be kind of observing the API and making changes based on what it sees in the Kubernetes API. This is a kind of distinct thing that runs the Python code that you define and responds to events from the Juju controller. And the reason that we do this is because while you get a fair bit of the functionality from a traditional Kubernetes operator, firstly, they're confined just to Kubernetes. And secondly, they're actually relatively limited in terms of their, day-end functionality in our view. And we think that this is a kind of easier way to provide testing and kind of bulletproof operations. So the really nice thing here is you write your operator, and you can also deploy a very similar operator using the same framework on machines and VMs, on bare metal, etc. So they are slightly different. If the application forks in jobs, is there a special setting to handle it? So you're saying that if, where we run that go serve command, for example, if that then forks into a number of other processes, is there a special setting to handle it? I think that's the question. The answer is not as such. So it behaves like a normal init system. So there is a little bit more information on the Pebble README about how we handle that. I suggest taking a look at that. And if you need any further information, I think Joe will be able to give you a bit more about that in the chat. So I am going to carry on then with the next section of the demo. Just take a quick swig. Okay, so as ever then, we're going to start in metadata.yaml, and we're first going to define some storage for our charm. So you'll notice at the bottom there, we're defining a storage map. We're defining a single said storage called webroot with type file system, and we're saying that we want that to be at location /srv. So that location in the case of a Kubernetes charm, so in our case, is the location that your shared volume will get mounted in your charm container. So inside the charm container where your Python code is executing, you can expect that shared volume to pitch up at /srv. You'll also notice that we're going to make a slight change to our containers map, and we're going to add a mount section. We're going to reference a specific storage, the one we just created, webroot, and we're going to give the specific location that we'd like to mount that in the charm container. Note that you can actually omit the location from the initial storage definition. It will kind of get mounted into a specific path. And then there's a whole bunch of events and additional constructs within the framework you can use to query that at runtime and say like, hey, go and get this storage by name and tell me where it ended up getting mounted, right? Go and get the path for it dynamically. To keep the code nice and simple, we're just going to use /srv for all of our stuff here. But if you go to juju.is/doc/sdk/storage, you can find out all the information you need about doing slightly more complicated things with storage. So I'm going to switch back to VS Code and just make those changes to our metadata file. So we're going to define one storage called webroot. It's going to be a type file system. Note that you can also create storage of type block. more commonly used inside your kind of machine VM type charms, but that would allow you to assign block devices into your charms. And you can also specify a bunch of options here, like the number of them. So you might say, you know, a block device of 10 gigs, and I want 5 of them mounted into the application when it's deployed. Here we're just going for a nice simple file system, and we're saying that inside the charm container, we want it mounted at /srv. We'll then go ahead and add that to the GoServe container. So we'll just specify the storage, and we'll specify where we want that inside the charm container. We'll just put it in the same place. So that covers us for metadata.yaml. We're now going to need to make a quick change to our GoServe layer method. So the application we're deploying, GoServe, will take an environment variable called webroot, and if it gets that environment variable, it will try and read a kind of website from that path. So in this case, it will look in /srv and try and find like an index.html file or try and serve a path. So the way it actually works is when you type in your kind of pod IP /some path, it will first check if there's a file in the webroot named as the path that you typed. If there isn't a file, it will then search for a redirect in its map of redirects and try and serve that up. If it can't find either of those things, then it will serve up a 404 page. So we'll just go back and make that change to our Pebble layer now. If I jump into the charm, and all we're going to do is add something to the environment dictionary to add another option. And we're just going to say the webroot is at /srv. Finally, we are going to add an onInstall handler. So this is when the install event is fired by the controller at the agent inside your charm container. This happens once during the charm's lifecycle and only in response to a Juju deploy. So when you run Juju deploy, you get an install event handler once. It doesn't fire when you upgrade the charm, so it won't happen if you run a Juju upgrade. It doesn't happen when you do config change. It only happens on that first deploy command. So let's just quickly make those changes now. We're going to add another listener here. So we're going to say on install, and we're just going to define that method up the top here. This will also get an event, but we're not going to use it, so we'll just blank it out with an underscore, and we'll say handle the install event download the site. And this is just going to be self.fetchSite, which we will implement in a moment. So if I just bring you back to the slides, we're now going to implement the fetchSite handler. So this is a super simple, very naive handler that is just going to go and fetch a single index.html file from a GitHub repository and drop it into /srv/index.html. Again, disclaimer here, you'd probably want to do a couple of things if this was a production charm. First, you probably wouldn't hard code the storage path there. You would probably use self.model.storages and kind of query those storages that have successfully been attached at runtime, get the location for that storage and use that location. But we're just going to keep the code nice and simple here. This is relatively simple, so this will work just fine for our purposes. So I'm going to grab that code now, and then we will walk through it step by step in the editor. So I'm going to drop fetch site down the bottom here under the GoServe layer handler. So we're first just setting the site source. So if we look at what's at that URL, if I just grab my Chrome window up, you'll see that that is just an HTML file with a bunch of images and links on it and some star sheets kind of in line. So nice and simple. I'm then setting a maintenance status. So you'll recall that firstly, we can set messages inside our status, and you should see that appear in Juju status briefly. And remember that maintenance status means I'm doing something, but I'm expecting that I can recover myself back to active status. We'll also drop something into the log. And finally, we'll use URL-lib to grab the content at that URL and drop it into that single file there. And we'll set back to active status when we've done that. So I'm going to just import URL-lib at the top here. And then if I just switch back to the slides briefly, we're going to charm graph pack. This time we're not going to do a Juju refresh because you'll remember I said we've just implemented the install method, which is only fired in response to a deploy. So if we were to do a Juju refresh, it would get the upgrade event instead, and we haven't implemented that yet. So we'll remove the application from the model completely, and we'll redeploy it, and then we'll watch the output and double check that we can in fact get our landing page once that's deployed. So we should, if all goes well, be able to see a landing page that looks a little bit like this by the time we're finished. So if I go back into the terminal and I'll grab Tmux up again. So we'll do a charmcraft pack, and we'll remove the application from the model. That'll take a few seconds, and then we'll deploy the application back to the model using the new charm file. How does maintenance status interact with readiness liveness probe? So that's a good question. It is currently orthogonal, right? So maintenance status is just used to basically report the status into this Juju status here, and you can actually get a history of all of the different statuses and messages that were set throughout the time that the charm has been deployed. There isn't a tidy way to define liveness probes just yet, but that is actively being worked on and should land over the next few weeks, I'd have thought. So the pace of development on Pebble specifically is quite fast at the moment, so you should see some nice new features landing pretty quickly. So let's get that deployed. I might be able to just quickly show you that status log I was talking about. So you can go Juju show status log of a particular application, of a unit, which is to wait for it to deploy. You can see there, that's the status log, right? So you can see all of the different statuses we've been through, right? We've got allocating, waiting, idle, running, executing. We've actually got an error. Good. Well, this is actually a reasonable opportunity to show you how to kind of troubleshoot this stuff. So you'll note up the top here, we've actually got a Python runtime error being thrown into the debug log. And it's basically because I just forgot to import maintenance status into the code. So what we'll do is we'll just collapse this back down. We'll just add maintenance status in here, save that. And then I'm going to rebuild the charm with charmcraft pack. I'm going to remove the application from the model. It'll take just a second. And then I'll redeploy it, right? So I'm going to Juju deploy once that's been removed. And in a couple of seconds, we should be good. He says, I'll just take a quick look over the questions whilst that's going. Oh, there aren't any more. Good. This question about relations, I see. Yeah, we'll grab that. We'll go on to that in a little bit later on. There is already a Prometheus charm, in fact, in the Charm Hub that does implement some relations. Okay, we're back to active idle status. So what I was trying to show you a second ago is there is a status log for a specific unit, right? So you can see executing active maintenance, right? So you can see there at some point during this charm's life cycle, we set maintenance status and said fetching website, and that kind of marries up with the code that we just set in our fetch site handler here. We should now just validate that what we've done works. So if I just curl that URL now and put 8080, I should get what looks like a page. So if I jump back into my browser and I go to that IP address, you now get a nice pretty landing page, and you get links to all of the different community things, the Charmed Operator Framework docs, etc. So that's worked nicely. So we're now going to move on to the next stage of the demo, where we'll talk about implementing an action. So you can grab all the code for the next stage by doing git checkout /action. And that will set you up nicely for the next part of the demo. Looks like there's another question in the chat. So will Kubernetes kill the pod if liveness probes fails and it gets restarted? Yes. So if there is a liveness probe specified, then it will kill the pod. At the moment, what we lack is the ability for you to specify that liveness probe yourself in like the, using a Charmed Operator Framework abstraction. So you can, one of the things you can do at the moment is using that kind of Juju trust mechanism I spoke about earlier on. Once the charm's up and running, you can then use the K8s API to manipulate the stateful set and say, actually set a liveness probe on this podspec template, and that will then kind of persist, right? It won't get overridden. So then you can kind of set your own custom liveness probes. We are hoping to add some capability for that into Pebble in the future. Yeah, so Juju show status log, that's right. Thank you for that. So if there aren't any other questions, then we'll move on to the implementing an action phase. So you probably guessed it. The first thing we're going to do is into actions.yaml. This is somewhat more complicated than config.yaml. So we're only implementing a very simple action here that doesn't take any parameters. So we're just literally going to set the name of the action, which is pull site, and a description. But you can use a kind of nested JSON schema in here to specify a set of parameters, some of which are optional, some are required. You can set different data types on the parameters. You can set enums so that you've kind of got a list of things people can pick from. And there's a lot more information about that at the link at the bottom of the slide, including a couple of relatively complex examples. For now, we're just going to keep it really simple. So if I just switch back to the code and jump into actions.yaml, I'm just going to grab this template placeholder and get rid of it, and we're just going to do a pull site action, and we're going to say pulls latest version of the site from GitHub. You can see here the one that comes out the box, the example that comes out the box does in fact take some parameters, and you can set for the parameters kind of a description, a type, whether or not it's optional, and there's a whole bunch of other things that you can see by going to that docs link on the slide. We're just going to drop all of that for now to keep it nice and simple. Save that file. And the next thing we need to do is implement a handler. So we've just defined the pull site action. Every time that is invoked by an administrator, there will be an event emitted to the agent by the controller called pull site action. So the pull site action event, right? So we'll just change our init function for our charm and observe that event and assign a callback to it. And that callback is just going to be really simple. It's just going to call the fetch site method. If we'd have called our action something like update site, then we would get an update site action, an update site action event emitted from the controller, right? So you're always going to get an event that's kind of named after your action with _action tagged on the end of it. Hopefully that makes sense. Do drop a message in the chat if I've just made a mess of explaining that. You'll note in the callback here, we actually do use the event parameter. So you can call event.setResults and set a kind of dictionary of results. You can also call event.log and add log messages, which probably not particularly useful for this action because it will run really quickly. But if you had a long running action, like some kind of replication, some sort of backup, then you might want to put log messages throughout so you can kind of track the progress of that. And finally, there's also event.fail, which allows you to set a message to say, this event handler has failed, the action has failed, this is why. So if we just drop back into the editor and go ahead and implement that now, so let's jump into the charm code. So the first thing I'm going to do is just add the handler up in the init method here. So we're going to say on pull site action, and just to match the slide, I'll just get rid of the on there. And then we'll drop that down at the bottom. So this is going to be def pull site action. And I will put some logs in here just so you can see what that looks like. So this is an event log message, and we'll say starting to pull site. And then we'll actually call our self.fetchSite method, and then we'll say event.log site pulled, and we'll also do a set result. So event.set results. And that will take a dictionary, and we'll say result is site pulled, and we'll set something else just for fun, like some key, some value. Right, so just to demo how that works, and that should probably get us nice and set up. If we drop back to the slides briefly, then what we're going to do now is repack the charm, rebuild it. We're going to do a Juju refresh to deploy the latest version of the charm. And then we're actually going to trial, this is actually an upgrade on this morning's presentation. We're going to trial out a new user experience that's available for Juju, where we just have to set a feature flag to say we want to use the latest kind of actions experience. It was highlighted to me this morning that this is available, and it is actually a much nicer way to kind of interact with actions on Juju. So we'll do that, and we'll just explore some of the things that you can do with actions, how you can manipulate the output from them, send them into the background, query the status of them, that sort of thing. So if I just switch back to the terminal, we're first going to do charmcraft pack. I'm just going to resize this a bit, and then we're going to do Juju refresh and wait for that. Great. We're just going to check that that feature flag is enabled, so you can do that with the export Juju features equals actions-v2. And then I'm going to run Juju run hello kubecon pull site, and you'll see that that will essentially come up and give me each of the log messages that we specified there, right? So you'll remember that in that particular handler, I set event.log, this is an event message, event.log starting, event.log site pulled. So you can see that there. You can also do Juju run, and you could say format YAML. So that will do the same thing again, but it will kind of give you a YAML output. It's actually just failed. I don't know why. What's happened there? Some key must start and end with. Oh, I've actually messed up in my quest to do something slightly more interesting with my handler. I've actually done something it didn't like. So I'm just going to set that to key, and then I'm going to redeploy that charm. You'll see there's a whole bunch of errors up here because I did something it didn't like with the results dictionary. So we'll just deploy that now again. And wait for that to update. Has anyone managed to follow along, Pat? Are you hanging in there with getting this deployed? Hopefully. So good, we're back to active idle again, so we can now run that pull site command again. So waiting for task 6, it will drop the log messages, and hopefully this time we'll get the results. There we go, right? So this time we got our results dictionary. I thought that was a bit strange that didn't come up. And just to reiterate, you can run that run with a -- format equals YAML, and you will get slightly more interesting information. So when you run it with -- format YAML, you will get the kind of full information, right? So all of the log events, the kind of output of the results dictionary that we set, and you'll also get some information about the timing. So when it was in queued, started, when it completed. Clearly here, they're actually all in the same second. It ran so quickly, but for a longer running job, you can kind of see why that might be useful. You can also send a job to the background with -- background, and it will tell you kind of how you can query that later on, right? So we can now do a Juju show task, and show task number 10, for example. That just gets us the result, but if we set the format again to YAML, we get a whole bunch more information. You can also do a Juju show operations. Sorry, is it Juju operate? Juju operations, there we go. And you can kind of see a full list of the operations. And I believe you can also here query and say, only show me the failed actions, show me the completed actions, those sorts of things. So actions can be really, really powerful. We've done a really kind of basic example there that just sets a couple of log messages and fetches the latest version of the site. So that's great. So we're going to move on to relations, libraries, and ingress now. The reason these are all grouped together is because it kind of works quite nicely for the demo. Hopefully that will become clear. We're going to do a bunch of kind of theory type stuff now. So you can grab the code as ever with git checkout and then that branch that's displayed on screen. But I'll do a bunch of kind of theory stuff to just talk a bit about how relations work, how libraries work. So if you were to have a deployed model that looked a bit like that, so for those of you interested, that's the Kubeflow Lite bundle. You'll see that each one of those operators that's deployed will be focused on doing one thing and doing it well, right? So there'll be one that's really focused on driving the various bits of Kubeflow, the various Jupyter server, right? Each one of those things is focused on doing a thing. You know, the Istio operator is focused on driving Istio. The lines in between them are the explicitly modeled integrations that we know as relations. So what's happened here is someone could have deployed each of these charms individually and then said Juju relate Istio to that part of Kubeflow and Juju relate Jupyter server to Istio. Or you can define all of that in what's called a bundle file, which kind of shows all the bundle file as a description of a number of charms to deploy and the relations between them and the config for each of them. When you tell Juju to relate to apps, it's all done through propagating events from the Juju controller to the individual charms. So while the events are propagated from the controller, the charms do speak directly to each other, right? So in this case, we've got Mattermost and Postgres on the slide. Where if we were to relate those two applications, they initially learn about each other through the relation joined event and the information that comes with that event, but they would still be talking to each other directly from that point onwards. So really, it's kind of that initial piece is kind of about service discovery, which why is kind of a solved problem on Kubernetes, right? You get your kind of inbuilt cluster DNS. It's very easy to find other services on your cluster. Where the real power of this is if you're running multi-substrate deployment. So if you've got PostgreSQL on bare metal and you've got Mattermost on Kubernetes, you can still relate those two applications, and that relation process and those events that are emitted to those charms carry all the information that those two applications need to understand how to find each other and how to talk. There are kind of two types of relations. We're going to focus on what's known as a requires provides relation. So here, the Mattermost charm will define requires, say that it requires the PGSQL relation, and the Postgres charm will say it provides the PGSQL relation. And these are essentially, they're called interface names. And so two charms that specify, so if a charm specifies requires and another charm specifies provides, and it uses the same interface, then those two charms are compatible for relation. One thing to note is that the relations are loosely typed. So the kind of matchmaking, if you like, is only done based on the interface name, and it's kind of down to the charm developer to do the diligence and ensure that those interfaces are implemented correctly. And one way that you can do that is using a charm library, which I will actually demonstrate a bit later on as a way of kind of codifying those relation interfaces. So if you were to issue the command juju relate Mattermost Postgres, the first thing that happens is so Pat, I think I'm about to answer your question. Each relation, so each instance of a relation is stored kind of persistently in MongoDB on kind of in the Juju database, right, the controller database. And that relation holds a bunch of data about each side of that relation. So for each side of the relation, there's what's known as a data bag. And inside that data bag, you have an application data bag and a number of unit data bags. So if we had Mattermost deployed with 3 units, each side of that relation object would hold some application data, which is relevant to the whole Mattermost application, and also some data about each of those units that Mattermost is deployed. So say we had 3 units, there'd be 3 unit data bags. The way these work is that the application data is read-write by the application leader. So whichever the application leader is, and the unit data bags can be written by the individual units, but all of the data can be read by all of the units. So any one of unit N of PostgreSQL can read the application data bag of Mattermost. Unit 0 of Mattermost can read the application data bag of Postgres, or the unit 2 data bag of Postgres, right? And so all of this relation information is stored persistently in the controller database. Hopefully that makes sense. So I'll show you how that gets built up now. So when we initially do the relation, when we say juju relate Mattermost Postgres, both of the applications get a relation joined event, and that relation joined event carries with it some information like this is the IP address of the other application, this is how you find it. So it's kind of alerting both of those applications that they've been related. The Mattermost charm is probably going to as a result of that, has been programmed to say, okay, I've got a relation. I'm going to set my application name or my app name in the app data bag to Mattermost, right? So this is Mattermost saying, in my application data bag on this relation, set my name to Mattermost. Anytime the data changes in a relation data bag, all of the charms, all of the units as part of that relation get a relation changed event to say, hey, somebody's changed something in the relation data bag. So that's what's happening there. The PostgreSQL charm has got a handler on the relation changed event that says, okay, I'm going to read the app name. If something sets a new application name, I'm going to create a database named after that app name, and I'm going to create some credentials for that database. It then sets its application data in its application data bag to those credentials it's just generated, and because something has changed in the relation data bag, the Mattermost charm then gets an event to say someone's changed something in the relation data bag. It's also worth noting that this is a trivial example, and the more astute amongst you might be asking whether it's a good idea to be setting database credentials in the relation data bag. The answer is it sort of depends on your threat model. They are stored sort of in plain text. The communication is all done over TLS, kind of between the agent and between the controller. So the communication itself is encrypted, but they're not the things you're setting in that data bag are not encrypted at rest. One way that you could get around this, though, if you needed to share sensitive information, is either in your relation data changed handler, you could offload to some third-party secrets provider, perhaps Azure Key Vault, perhaps HashiCorp Vault, or you could use it for each of the units to exchange public keys and then just exchange encrypted information only. But we'll keep this example nice and basic. So now the Mattermost charm has been told about some credentials it can use to create a database. In the charm code, we can write the config file out to say, hey, Mattermost, this is where your database is. This is how you connect to it, and start the process using Pebble. And that relation is now essentially fully formed. So if we kind of play back what just happened, the end state of that relation data bag is that you end up with an app name set on the Mattermost side and some database credentials set on the Postgres side. And that information is persisted into the controller database. And every time you scale one or other of those applications, all of the new units will be able to read that data and act accordingly. So we're now going to move on briefly to talk about an ingress charm, and you'll see why shortly. But the Nginx ingress integrator charm is an example of a charm that interacts directly with the Kubernetes API. So it assumes the presence of an Nginx ingress controller. There are some charms on the way that actually deploy an ingress controller onto your cluster, but this one is more like a proxy charm, if you like. So it assumes that you've got your ingress controller deployed already, and all it means is that you can deploy your ingress integrator charm, you can deploy the application charm, and when you relate the two, the web application tells the ingress charm, hey, this is the host name I'd like, can you build me an ingress? Right, so you can essentially go deploy web app, deploy ingress charm, relate the two, and you magically have an ingress provisioned that allows you to kind of access that from outside your cluster. There's more information about that Nginx ingress integrator charm at the link below. I am actually just going to quickly show you that because it's a little bit more interesting in terms of the information provided than the one I showed earlier on. So if I just go charmhub.io, Nginx ingress integrator, you can see here there's a lot more configuration options that have been parsed automatically by CharmHub and kind of populated onto this page to make them a little bit more discoverable. So we talked about charm libraries before. So charm libraries are essentially just a way that you can share code with other charm developers and they can share code with you. It works kind of similarly to PyPy and NPM, but it's a lot simpler. So charm libraries tend to be single files. They don't require any separate build infrastructure, any separate distribution mechanism. You do all of the interaction with them through Charmcraft, so it's all just the same tool. And one really nice use case for this is for codifying those relation interfaces. So we spoke earlier on about how if two charms define a relation that with the same interface, they're broadly assumed to be compatible. Well, one way that you can assure compatibility is by saying, well, I own the Postgres charm. I've defined what I think I should be receiving, what information I need over that interface. So I'll provide a library with a nice, simple to instantiate class or helper method that allows another charm author to implement that interface correctly and kind of make sure that it behaves as we'd expect. So we're going to use the Nginx ingress integrator library. If I just drop back into the page here, you can see under the charm page, if you go to libraries, CharmHub automatically shows you the details of that library. It shows you the documentation for that library, and it parses the doc strings in the Python library and kind of renders it out nicely so you can see exactly what that library provides and how you might use it. So if we go back to the slides then, there's a couple of things we can do with Charmcraft. In addition to actually publishing a library, which we won't show today, you can list all of the available libraries for a charm and fetch a library into your project. So this is essentially saying, hey, I found a library I want to use. Charmcraft, go off to CharmHub and grab that and put it in the right directory in my project for me. So we'll just do that now. I'll just get rid of that browser. So if we do list lib, so Charmcraft list lib, you can see that there is one library associated with the Nginx integrator charm, and it's at patch level 5. So that's where the author has published a number of revisions. And we can also do fetch lib to grab that library and drop it into our charm directory. So if I just shrink that down a second, you should now see a lib folder in your charm directory. And you'll notice it's created kind of a bit of a directory structure so that Charmcraft knows in the future where to drop later versions of the library, etc. And in there, you can see, firstly, all the instructions that were published as kind of the library documentation. You can see how that was just parsed straight out of the code file into CharmHub to make it nice and easy to read. And I think it's also worth just looking at what's actually in this library to explain that there's nothing particularly scary in here, right? So you'll notice the ingress requires class, which we're about to use, actually is just setting up another event handler for the ingress relation changed event, and then it's implementing some checking to make sure that we're specifying the right kind of config or the right kind of information over that relation. And then finally, it specifies a handler, right? So we're essentially handling the relation changed event, but through a library that the charm author has specified. If you've got any questions about exactly how this works, ask Tom, because it's his charm. So if I just go back now to the slides, we're going to take a look at how we might actually integrate that. I'll just take a brief moment to answer some questions and then we'll carry on. So it looks like Mark's jumped in and answered a few, so I'll just grab a couple at the bottom. So are libraries semantically versioned? Are they handled appropriately? Yes, they are semantically versioned as such. So you have a kind of major and minor version, and you can kind of choose which version you want to import into various versions of your charm. And you'll actually see that on screen at the on the next slide. You can kind of import various different versions of the library into your charm and kind of handle that. If you were upgrading through the life of a charm and you were about to integrate a new version of the library, you'd import that in the new version of the charm and perhaps implement the upgrade handler, which might do anything that you might need to do to kind of change anything underlying in your charm that was tied to a specific version. Yeah, it looked like we grabbed v0, which took 0.5. That's right. So the major version of this charm API was version 0, and the minor version, the patch version, was 0.5, right? So that's exactly as we'd expect. So let's get on and actually start implementing this relation then. So the first thing we're going to do is jump into our metadata.yaml. And at the bottom of that file, we're just going to specify a requires relation named ingress with an interface of ingress. Note that it is the interface name that ultimately is used to decide whether two charms are compatible. So you can name this whatever you see fit or whatever kind of makes sense for the context of your application. So we could call this, Kate's ingress, or, whatever you want, Steve, but we'll just call it ingress for simplicity. The point is you can name the relation whatever kind of makes sense in the context of your application, provided the interface name is the same as the charm that you're relating to. If we look back now at the slides, you can see at the top here how I'm going to import version 0 of the library here, right? So that first line there, we're going to import version 0 of the charm library from our charm source code. And then we're going to just initialize that ingress requires class in the charm init method. And we're going to pass a service host name, a service name, and a service port, which is the required information that the charm author has kind of specified. And that was actually in the documentation for the library. So there's actually an example here, which we're pretty much going to follow to the letter. So if I just drop back into the editor, I'm going to grab that import and copy and paste it so I don't typo it, because I'm hopeless at typing today. And then we're going to initialize that class in here. So we'll say self.ingress equals ingress requires. We'll pass our charm into it, and then a dictionary of config options. The first thing is the host name that we want the ingress to respond to. I'm going to set that to hellocubecon.juju. We're also going to set the service name. So this is the name of the Kubernetes service that the integrated charm is going to create. And we're just going to use self.app.name. So this is quite interesting. This is actually grabbing the name of the current application. So like in the context of this code that's running, it'll go off to the model and say, hey, what's the application name on the model? Let's use that. And you can also get the name of individual units, right? So you could say self.unit.name, for example. In this case, the application name is sufficient. And then finally, we need to tell it the port that our application runs on, which is 8080, as you'll remember from our curl commands earlier on. There's a whole bunch more information about libraries at the link at the bottom of the page, and also a description of peer relations, which are used when you have clustered applications. As you kind of scale applications out, peer relations are automatically populated. So if we were to create 5 instances of this application and define a peer relation, they'd all kind of get a bunch of events fired as new units added and removed from the application, which allows you to handle kind of cluster leadership and kind of maintenance really, really nicely, using that exact same abstraction of a relation data bag. So you can kind of help that coordination piece if you need. So now we're going to do a quick test deployment. So I'll just switch back to the slide, sorry. We're going to end up with a pretty similar result to last time, I hope. So we'll have a landing page with a bunch of redirects, but we're also going to deploy that Nginx Ingress Integrator charm from Charm Hub. We're going to relate it to the Hello KubeCon application, set a config option. So we're doing this because MicroK8's, the default kind of Ingress controller, has an Ingress class of public. So we just need to set our charm to match that. And then I'm also going to add an entry to my host file so that I can resolve the hellokubecon.juju domain, which I've clearly just made up. You don't have to do that. I can show you how to test that it's working if you don't want to modify your host file, but that's what I'll do for the sake of the demonstration. So let's drop back into VS Code then. Firstly, we'll do a charmcraft pack to build the charm. Check out it actually save that file. Yeah, we're good. And then we're going to do Juju refresh to redeploy the latest version of the charm. And then we're going to do Juju deploy the Nginx Ingress Integrator. So Juju will now go off and fetch that charm from Charm Hub, download it and start it. And we're going to Juju relate Hello KubeCon to the Nginx Ingress Integrator charm. And finally, we're going to set that config option for the Nginx charm just to make sure that the ingress, the class of the ingress that we create, matches the ingress class of the controller that MicroK8's provisions by default. And now we just need to wait a couple of seconds for that to all come up. You can see that in my host file, I already have that kind of bogus entry, if you like, for hellokubecon.juju. If you don't want to do that, you can use curl to achieve the same thing. So you could, for example, you can use curl with the tap h, so something along the curl tap h host hellokubecon.juju, and then the URL of the pod here, and that will achieve a similar thing. But I'm going to assume that you've done the cool host file trick, and you can see now that the Nginx Ingress Integrator is fully deployed. It's in active idle, and it's reporting that it's created an ingress with a service IP of that. Note there's also a quick trick you can do with Juju status. You can do Juju status -- color -- relations. And that will also show you, it's a bit ugly because the screen's a bit zoomed in, but it will also show you all of the relations that are currently present on your model. I'm just going to go back to my watch view. And we're just going to check that if I curl the hellokubecon.juju, hellokubecon.juju, we're getting that page, right? So if I drop back into the browser and I go to hellokubecon.juju, you've now got that nice landing page being served up over a Kubernetes ingress, and all of your redirects should still work, right? So you can get to the Python operator framework, the Pebble code, and a few others as defined in that map. I think you can get straight to our chat as well if you wish, so that will take you straight to Mattermost. I'm also just going to do a bit of exploration with kubectl so that we can just kind of see exactly what's just happened. So I'm going to go to a slightly cleaner terminal. It's nice. So if I do a quick K development, get pods, you can see we've now got 3 pods running. So we have the model operator that we had before. We have the latest version of the Hello KubeCon application with its 2 containers running. And we have the Nginx Ingress Integrator pod because we deployed that application alongside. We can also see that we've created a service. So that is the, where are we? Hello KubeCon service here with the cluster IP that was reported in the Juju status output. So we could describe that as well. So if we do describe, let's just have a look at that. So this was all created by the Ingress Integrator charm. There we go. So you can see it's got a label that's been created automatically, and it's kind of got all the configuration to point at our application in its pod. And finally, if we look at the ingress that was created, so and then we could also describe that ingress, and you can see all of the bits of config we did, right? So the ingress class that we set manually from the command line, the host name that we set when we were initializing that charm library, and pointing it at the service that was created automatically by that library. So hopefully that's a reasonable explanation of what's just happened by using that charm library. I'll skip over that. Before we move on to unit testing then, I'll just take a quick break to answer any questions. So I'm just going to scroll back through the chat if you bear with me for a second. So where did I get to? We had a bit of a chat about Charm library versions, which is good. Is there support for private Charm registries? I believe you can do that. So where the Charm, so I think you can have a private Charm, sort of Charm hub, if you like, specifically because we're now actually, the way charms are built and published into channels, kind of all the machinery is the same on the back end as it is with snaps and the snap store, right? So similar sort of methodology for snaps and charms in terms of release and distribution. So I believe that you can have a private charm hub. I don't have the details of that, but I'm sure if you follow up on Discourse or on Mattermost, then someone will be able to answer that for you in more detail. You could also do a Git repo, probably a bit hacky, but I'm sure it would work. Best practice resources for designing operators. Yeah, so Tom's right. Like I actually wrote the operator framework SDK docs that Tom linked to there a few weeks ago. I've tried to, wherever possible, kind of coerce as much of the kind of best practice guidelines that have been thrown around internally and get as much of those into that documentation as possible. Equally, if you've got a question about kind of style or whether something's a good idea, that sort of thing, absolutely feel free to drop that into one of the Mattermost channels or on Discourse, and someone I'm sure will get back to you, or at least be up for a bit of a discussion about it. But yeah, there's also some documentation which I think is going to get released shortly, which is about kind of well-architected operators and the sorts of things that you might want to avoid or might want to do explicitly. So moving on to unit testing then. This is the last phase of the kind of programming demo, if you like. So you can just check out the master branch. There will be a total of 4 unit tests in that branch. We're going to run through the kind of implementation of 2 of those right now. So we mentioned right at the start that the Charmed Operator framework has a kind of fully featured test harness that helps simulate the life cycle of a charm without the need to kind of repeatedly redeploy. So if you want to write code and iterate quickly without constantly waiting for the charm to upgrade and redeploy and remove, etc., hopefully the unit testing harness gives you that kind of first level of validation and also an illustration to other people that your operator is well tested and is likely to do the right thing. This is something that we think is a real advantage for the Charmed Operator framework, is this kind of notion of a strong testing harness in a way of validating things before you deploy them. So if we jump right in, we're going to just demonstrate how you can just use the kind of standard Python testing framework. And what I'll do is actually, I've had to clip the code a little bit on this slide because there's a bit too much of it. There's loads more detail about this at the docs link at the bottom of the page. But I'll just copy and paste one of the tests into the editor and we'll walk through step by step some of the rationale behind that test. Okay, so we're first going to test our GoShare layer method to make sure that it responds as we would expect. So if I just bring this up, you should have a tests folder and from your kind of init, and inside that you should have test charm. I'm actually just going to delete pretty much everything that's in this apart from the setup method, because this is all boilerplate that comes from the template. So when you run charmcraft init, you do get a bunch of working tests that will pass and kind of give you an idea about some of the things that are available in Harness. We're going to walk through those now. So firstly then, you're just using Python unit tests, right? So if you're familiar with Python unit testing, this should feel very normal to you. We're defining a setup method here, which will run before each of the test cases. And in this case, we're just instantiating a thing called Harness, which is part of the Charmed Operator framework and is our kind of bespoke testing harness for Charmed operators. We're adding a cleanup, which is fairly standard kind of Python unit test stuff. And then we're calling self.harness.begin, which will essentially instantiate the charm as it would be on a deployed system. It's worth noting that it doesn't actually fire any hooks, though. You can simulate that if you want. So there's also self.harness.begin with initial hooks. If you were to call that instead of begin, you would essentially get the full set of kind of install, config change, start, Pebble ready hooks all being fired automatically as if you were deploying the charm from scratch. So that might be nice for kind of like an end-to-end test, but we definitely don't want to do that for every single test case. The first test case we're going to cover is the GoShove layer test, right? So we're just going to double check that the method we've written to generate Pebble config layers is doing the right thing with respect to any configuration set on the charm. I'm just going to do a bit of rearranging to make this a bit easier to use. So the first thing we're going to do is imagine now the charm has been instantiated, it's been started, but no one has kind of defined any relations, no one has set any config, so we would expect any layer that we generated to come out the box with the kind of default that we specified. You'll remember from the charm code, our GoShove layer returns this dictionary and it defers to self.config to get the redirect map. And if we take a look at config.yaml, you can see that we set the default to this value here. So this unit test is just really simply testing that the dictionary comes back as we'd expect with the right web root set and the right kind of default URL set. So we create our expected so we first just check that the config is set correctly, then we generate an expected result from running GoShove layer, double check that that is the case. And then we're going to call disable hooks, which is a special method we use. Normally, if you were to call self.harness.updateConfig, you would trigger a config changed event as you might expect, right? That's essentially the equivalent of running juju config from the CLI, but in code. Because we're not actually interested in testing the config changed event at this time, I'm going to disable that so I can kind of I can update the config in the underlying model. I can set that config, and then all I'm going to do is test that the GoShove layer can kind of read that. So we disable the hooks, we update the config, we change the expected dictionary slightly so that we kind of, we're expecting the value we've just set, and then we validate that the code is doing what we expect. So if I just pull a terminal up briefly, we're going to use the run tests bash script that comes with it. So you should remember that there was a run test script included in the template. So if you just run /run tests, that will automatically source your virtual environment and run your tests. The first thing it runs is Flake 8, which has immediately reported some problems because I've done a whole bunch of copy and paste and not commented out some imports that I'm not currently using. So I'll just do that now. And now if we run the test case, you should see we've got a single test called test GoShove layer. And that test passes, and we get a nice kind of coverage report at the end to tell us that we need to write lots more tests. So we'll try and do another one of those now. We're going to test our config changed event, and I'm again going to just copy and paste this in and walk through it kind of line by line. I'm just going to take a quick glance over the chat because I've seen that scrolling up to my left. So Pat talking about differences with the Red Hat OLM. Yep, thank you, Tom. We do have an operator, some custom stuff for Red Hat. Yes, so that's a really interesting question, Pat. So this is, can we package existing operators? And I think the answer is almost certainly yes. I'll actually be personally working on this over the next couple of weeks, taking a couple of existing Red Hat operators and seeing if we can sort of unify the experience of a bunch of different operators and wrap them in this framework, which will allow us to do kind of more comprehensive unit testing, give a nice consistent experience, and kind of wrap them in some nice, easy to maintain Python code, and also more easily manage different versions of the operator, right, as they change. How do things work out? Air-gapped on-prem, so many things. So the answer to that question is kind of similar to my last one. So I think you can have custom Charm stores, Charm Hub deployments. You would need to set up a proxy for Juju that tells it, like, if you're going to go and get a Charm, you need to go and get it from here. Here's the URL. There is actually some options in Charmcraft itself. So Charmcraft has the ability to be told which store to publish to. We actually do this internally for kind of testing and staging, as you might imagine. So you can do that. I'd need to get back to you on any details. Pat, unsurprisingly, getting excited about the offline question. That's a classic. Great. How much of that did I just do with the wrong screen? That's a little bit awkward. Let me just pop back into the editor now to show you that. Hopefully that's now showing up a bit better. I was just walking through the test GoShove layer code. So as a brief recap, we just tested that the charm config was set correctly. We tested for an expected version of the dictionary based on that default config value. Checked that our GoShove layer returned that expected dictionary updated the config on the model, and then double checked that the GoServe layer method responds appropriately and populates the correct config. I'm now going to grab the config change handler that was on the slide I just switched from, and we'll walk through the kind of logic behind that test. So let me just drop that out of the way for a second. Okay, this is a little bit longer, this one. So if we just briefly refamiliarize ourselves with the config changed method, you'll recall that we are first going to get the container from the model. We're going to generate a new layer, get the current configuration layer from the Pebble API. If the two differ, we do a bunch of things to add the new configuration layer and restart the process. If they don't differ, we just report an active status. So if we go back to the unit test, we are first going to check that when the charm first starts up, there is no plan in the container, right? Because we ran begin and not begin with initial hooks, the charm should just be kind of instantiated in a blank kind of waiting state. So we just double check that the plan that's loaded in the container is essentially empty. We're then going to update the config. This time we're not going to disable the hooks because we do want the config changed event to fire because that's what we're testing. So we update the config, and then we get the plan from the container again and double check that that plan is the same as what's returned from GoServe layer, right? Because we would expect in our config changed event to be generating that layer with the GoServe layer method and then loading it into Pebble. So the two should be equal at this point. And then we double check that we're reporting an active status and that the service inside the container named GoServe is in fact running. This was an interesting test because at the point when this config changed event fired, the process wasn't already running. Now we're going to test what happens if we update the config again, in which case we can assume the process is running and we want to double check that it's been restarted or that it's still running with a new config, right? So we update the config, change to a different value, we get the new plan from Pebble, double check that it's been updated to the kind of expected value, and then double check that we're still running and we're reporting an active status. And we can run that exactly the same again with the run tests handler, which I failed to run. Flake8 has told me there's an undefined thing I'm using, so I'll just uncomment that again. And you'll see we've now got two tests passing and a slightly better coverage. As I said, there are a couple more tests in the master kind of branch that will give you a slightly better coverage, but that pretty much covers where I was going to go with the unit testing for today. So a quick recap of what we've just done then. We have just initialized a brand spanking new charm using Charmcraft init, and we've adapted that template to start our own workload. We've then handled some configuration in the form of adjusting the redirect map that GoServe uses to serve up its short URL redirects. We've generated an action and written a handler for that action to fetch the latest version of the landing page using the sidecar charm. We have used a charm library to implement a relation with another charm, which allowed us to define an ingress for Kubernetes. And we've also unit tested the operator using the Python unit testing harness that we provide. As a recap, the reason you might want to use the Charmed Operator SDK is hopefully you've seen that you get to write nice, simple operations code in Python. You get a consistent operator UX and CLI for all of your operators, irrespective of the application, the underlying substrate, the environment they're deployed in. You get that comprehensive unit testing harness, which is a real differentiator for us. You can test every single aspect of your operator from deployment to configuration to integration with other applications and to day N actions. And finally, our developer tooling has evolved nicely. So we have nice, simple mechanisms for code sharing and integration with libraries and other charms that people have developed. And also a reminder that you can join the charming community over at charmhub.io, discourse.charmhub.io for a sort of forum-based chat, and chat.charmhub.io. You should also definitely do our survey for a chance to win one of these really cool t-shirts that says I'm charming with an even better Canonical and Juju logo on the back. Thank you very much. I'm going to do a little bit more Q&A now. Feel free to fire questions in. If there's something else you'd like to see, let me know and I'll do my best to accommodate at the end of the stream. We could deploy some different things, try out some different relations. But otherwise, thank you very much for listening. So looking back at the chat, we've got some questions about Juju Trust. Yes, so if you look at my GitHub page, so github.com/, JNSGR UK, there is a Kubernetes dashboard operator in the very early phases of development, which shows an example of a charm that uses that Juju Trust API, right? So you use the Kubernetes API directly from in your charm code to manipulate things that would otherwise be kind of privileged inside your cluster. And in that case, I provision a whole bunch of service accounts, roles and cluster roles and role bindings, etc. So there's an example of that there, and there will be more coming soon, I am sure. What have we got here? Interesting to have Tom and Kate's front. There we go. There's no vendor lock-in. You can switch out if you want to. Absolutely. Yeah, you absolutely don't. I guess there's some lock-in to Juju if you use charms at the moment, but there's nothing to stop somebody else from writing an operator lifecycle manager. And like I said, while we would prefer that you use the charmed operator framework, and we think we've made that a great experience with the the various abstractions we provide and the unit testing, you can write charms in anything. There do exist charms written in just Bash. There are others in Go. So it's kind of up to you, but the charmed operator framework is likely to be the best experience, and it's the one that we're putting our effort behind. Then I'm going to have to watch this half speed again. Yes, indeed. This is going to get repeated. So it's going to get repeated later on today if you fancy staying up late, but it's also going to be available as a recording after the fact. So that will come out in an email, I believe, from Hopin. You can also jump into Mattermost and ask me any questions anytime. So I'm in there with the same username, JNSGR UK, and there's a good number of the Juju team and operator framework team, etc., who hang out in there as well. So you can always get help that way. What else have we got? I think that's pretty much it. So I think I've got a few more minutes till the next thing. I'm just going to double check the timing to make sure that I'm not going to overrun. So we've got until 4 p.m. So one thing I thought it might be interesting, unless there's anybody sat in backstage who wants to jump in and kind of underscore anything that I highlighted, then absolutely do that. But in the meantime, I might just show a couple of things about sidecar charms that are quite interesting. So one is what happens if you define multiple containers in your containers map. So you might remember in your metadata.yaml file for the charm you now have, we specified a single container called GoShare. We told it which resource to use, and we gave it a mount to use. You can define multiple containers, and as I said, each of the containers you specify in this map would all be present in each of the pods of your application, right? So I thought it might be interesting to just do a quick demo of how that looks. You can do this yourself. So there's already a charm published that does this. So if you just type Juju deploy snap pass test, this is a sort of reference charm that we've been using throughout the development of some of this stuff. And SnapPass is a really interesting little application developed by Pinterest, I believe, initially, which is a way of just kind of ephemerally sharing passwords. And it uses Redis as a sort of data store in the back end. SnapPass test actually defines 2 containers per pod. So if we look at Juju status now, I'll just set it to watch. I'm not sharing my screen again. Amazing. Thank you, Pat. So all I did there was Juju deploy SnapPass test and then Juju status watch again. So you should now see, if I zoom out a little, we've now got a SnapPass test unit running, and it's told me that it started the SnapPass container. And we should probably have a bit of a poke about in there with kubectl to see what happens when you specify multiple containers. So if I just come out of here and we go backend development, get pods, you can see we've still got our model operator, still got our 2 pods for Hello KubeCon and the Nginx Ingress integrator, but now we have SnapPass test running, which has got 3 containers running. So in this case, we're running, in fact, I'll just show you. Let's describe that pod. You can see in this case, we've actually got the charm container, as you'd expect. You've got the Redis container running. Note that that's also had its entry point overridden with Pebble. So Redis is being started by Pebble. And you've also got the SnapPass container running. So there's kind of an example. So if we were to scale that up, you would see that kind of replicated across, right? So if I were to do Juju scale application SnapPass test to 2, and we watch the status, you'll see another unit coming online. Okay, so we'll just wait for that to get into active idle status. Cool. So now if we take a look at what's in our model, so get pods, you'll see we now have snap past test 0, snap past test 1, and they're both running 3 containers. That one hasn't quite come up yet, but it will do in time. So you can see how the operator has scaled right alongside the application, so that it doesn't matter which node these get scheduled on, they'll always have an operator right next to them for any kind of actions or operations that may need to happen throughout the pod's life. My question is, my keyboard is so obnoxious. I'll take that as a compliment. Thank you very much. Can we control things like the security context and the like easily? So the answer is yes, but unfortunately right now the answer is use the Kubernetes API, right? Either load YAML into it or use the Python kind of, use the individual calls for the Kubernetes API and use that Juju trust mechanism. Again, not 100% on the exact roadmap myself for Pebble in the next few weeks, but there are a whole bunch more features coming around sidecar charms and Pebble specifically, so there may well be some more abstractions for those things in the future. Could we apply something like KEDA to autoscale charm operators? I'm not sure I know what KEDA is. Let me just have a quick look, and I'll hopefully be able to tell you. Event-driven autoscaling, I see. Yes, so I suspect probably, right? So I'd need to do a little bit more digging into how this autoscaling works. But I suspect probably, because you could write your kind of horizontal or vertical pod autoscaler as you normally would, kind of alongside Juju. So I guess in an ideal world, we would encapsulate that as part of a charm, but there's no reason why you couldn't kind of manually do that until such time. Or perhaps, Liam, you'd like to have a crack at writing that charm and publishing it on Charm Hub for us. My coworker insists on Go for the cloud. What was the reason to use Python? Good question. So nothing wrong with Go, clearly the language of choice for a lot of Kubernetes folk and the Kubernetes project itself. I mentioned before, if you've just joined us, you definitely can use Go to write charms. But really, we chose Python because it's just a little bit easier, right? The on-ramp is the on-ramp is kind of shorter. The curve is a little bit less steep. And Python is already used for a lot of kind of systems administration, like automation, right? So you'll already find it in a lot of people's workflow. The number of libraries is massive. The community is enormous. And we just felt like it was a really, really productive language to give people access to when they were building operators, to try and build them as quickly and reliably as possible and get them out and kind of accessible by the biggest audience. Yeah, and Mark's just mentioned there that, we don't necessarily handle things like concurrency in the charms themselves. The actual OLM, so Juju itself, is written in Go, and all of those sorts of things. So kind of event ordering in terms of how events are emitted and how charms are deployed, the order things happen. All of those things are handled by the OLM, by Juju, which is written in Go, precise and uses Go precisely for those reasons, right? It was kind of a better tool for that job. Good question. Thank you. So I was also going to have a little bit of a prod about, again, in Charm Hub. I thought it might be interesting to just spend a bit more time there. So a reminder that you can grab the full kind of published charm by going to charmhub.io/hello-kubecon. You can see the kind of README. You'll note that this README was the same one that was in the repository. So if we go to here, you can see that when I've run Charmcraft Pack, it's grabbed the same README file and published it into the charm on Charm Hub. This is actually, in some respects, going against my own guidance in the docs. Really, you want here to talk about what are the features of your charm. Try not to kind of give a big copy paste from the upstream application README to say, like, if you're writing a Postgres charm, don't write a massive long README explaining what Postgres is. Rather, try to outline the specific features that your charm has. What the day 2 actions are, what the various relations are, talk about any libraries that you might want to, that you might be providing and how people might use those. I'm going to take another look at the ingress controller. You'll notice under the ingress controller, Tom's written a great README here for this, but he's also provided some more in-depth documentation. And these are actually managed as discourse posts. So this is done using a really simple hack in your metadata.yaml. So I could, for example, if I just swap back to VS Code for a second, under metadata.yaml, you can actually specify docs, and you can specify a URL to a discourse post, right? So something like this, right? charmhub.io / and then a post ID. And that's exactly what Tom has done here. So if you'll notice that you can actually view the underlying discourse post here and kind of manipulate all of the navigation in CharmHub. So like this little sidebar here is all managed through a series of kind of markdown posts on discourse. And this is how you might provide really in-depth documentation, right? So keep the README nice and terse, like this is what this charm does, this is how you deploy it, here is the config, and then have any kind of more discussionary documentation, anything really in-depth about config or behavior in a series of discourse posts is probably the best way to go. We talked briefly about the charm libraries. Just to reiterate, your charm libraries are kind of all parsed, and there's a specific kind of style for your docstring. So we actually adopt the kind of Google Python docstring style. And if you adhere to that, you'll notice that, for example, where's a good example of this? You'll notice that this docstring here, for example, the ingress provides class will be translated automatically into some kind of nice looking documentation if you switch back into docstrings mode up here, right? So you can kind of annotate for return values, for parameters that are taken by methods and by classes. So hopefully makes the code nice and discoverable. And finally, we did speak briefly about the different config options that are kind of parsed and shown on that page, along with the actions. There isn't one for that, but there is for this charm. So you can see that action there. And if there were any arguments that you needed to provide to that action, that would also show up under that actions tab there. You can find this charm by going direct to charmhub.io /HelloKubeCon, but it's also featured at the moment. And we've just actually released this week, or rather the back end of last week, some functionality to kind of let you know if you've been around the charming community for a while, you'll have noticed quite a lot of evolution in terms of different frameworks. There was a thing called the reactive framework. And so we've started to indicate on the little kind of cards for each charm, whether things were written in operator framework, whether they're written in reactive framework, whether they're deployed on Kubernetes, and the kind of different functionality in terms of quality that these charms provide. So hopefully making really good charms a little bit more discoverable. And hopefully after today, there'll be a whole bunch more of these appearing after you find people go ahead and implement more for us and for the community. On the community, just a quick look at the forum so you guys know what to expect. It's a kind of standard discourse deployment. You'll notice there are categories for docs, so all of our documentation is maintained on here, which allows you to, if that's the sort of contribution that you like to make to open source, by all means contribute to our documentation. You can submit tutorials, you can put suggestions against existing docs, and that is all kind of automatically populates what is hosted at juju.is/docs. Specifically, you can look at the SDK documentation, and this is basically your Bible as a charm author for now. So I've done my best here to document as much of the charmed operator framework as possible. There are some really in-depth pieces on relations and specifically examples on peer relations, some guidance on interface naming. So if you're looking for in-depth information about how to build your charm, it's all there. And there's also some instructions about how to publish your charm, how to upload it to CharmHub. We haven't actually covered that today, but it's obviously a key piece of getting your work out there and getting as many people as possible using your charm. So if you go to doc/SDK/publishing, you'll see that there, including how to kind of upload and associate OCI resources for your Kubernetes-based charms. So I will probably stop talking for now. I'm just going to take a look and see if anyone's hanging around in backstage to jump in.
So why don't we just kind of come back and kind of reiterate what we've described here today from a technology point of view, from a sort of Kubernetes technology point of view, and relate this a little bit to what you'll see elsewhere from other people talking about operators. So the first thing I think is that if you sort of really dive into Kubernetes, a lot of people think of operators as a way to sort of dive into Kubernetes and have some code that futzes around inside the guts of Kubernetes. And that's important because, sometimes your application has to do all sorts of things sort of inside Kubernetes that it's just easier to capture in code rather than have a human sort of worry about. But what we're focused on is sort of like one click back from that and saying, okay, I've got things like those traditional operators, or I have other applications. How can I essentially glue these things together and create this more unified human experience effectively across operators from multiple different places? And the idea is to wrap that low-level stuff in high-level Python, right? And that Python is organized in a model. And so that Python is kind of very aware of the scale of an application, for example, how many shards are making up this application. That's where that whole conversation was about leadership, for example. If I've told Kubernetes I want to run 5 copies of something, each of those copies now is going to have a copy of the charm code, that high-level Python code, sitting in each of those pods. Those pieces of Python are communicating with each other over that peer relation. One of them is designated the leader. It doesn't matter which one, because that's really the control plane. The underlying application code could have a different one that is the leader of the application, actually serving the application. But the operators, those pieces of Python, the charms, are effectively agreeing amongst themselves how they're going to configure the individual pods, right? The behaviors of the individual pods. So you can see how, for example, if you have an application where as you scale it up, you're going to change behaviors. You're going to have to say, well, this is the primary, and these are the read-only replicas, and these are the standbys. It's those pieces of Python code inside each pod, the units, that essentially will decide that. The leader unit will essentially decide that map. It'll communicate with all of the other pieces of Python, and then they will drive the behavior of their individual pods sort of appropriately, right? So you see how now, at the scale of the application, you can create this richer sense of control of the application sitting on top of Kubernetes. When you're dealing with integration across applications, that's when you're dealing with the relation data bag and the idea that all of the units on this side and all of the units on this side, because I may have 3 front end and 2 back end, I could have complicated relation graphs, and I could also have different scales on either side of that. But all of those units are in communication with each other through that relation data bag. And the lead charm on this side can say, can make decisions for the whole application, all of the units here. The lead charm on this side can make decisions for all of the units over here. And by writing those decisions into the relation data bag, those lead charms can tell all units on both sides macro level things that both applications need to know about each other. And then each individual unit can also write some data about itself in from both sides, so that again, every unit on both sides, every pod on both sides of that relation can learn whatever it needs to learn, both about the big picture relationship between these 2 applications and the individual details, right? If there's something you need to know about talking to that specific pod over there, you can learn it this way. So this is a sort of very high level framework for integration between operators, right? And that wraps around what you'll see from other folks where they're talking about the actual operators going down into Kubernetes, right? What we're talking about is, okay, great, you've got all of those operators. How can we essentially design operators which integrate really nicely? And then because all of those operators are inside this model, right? They learn about that relation from the model. We create this consistent user experience. I don't actually go in and talk to the charm itself, the operator itself. I'm actually just describing changes that I want in the model. And that then gets replicated down to the charm. So I have a consistent user experience no matter what application I'm working with. If it's a database or it's a message queue, or if it's a front-end application, it doesn't really matter, right? I'm essentially just updating the model, the scale of the application, the integration between the applications, the configuration of an application, and that's then replicating down to all of the pieces of code which are doing the actual work.